Right. So if you can recall very well, I did some things like just proving sets, of which we started something like maybe like some set rows. If I'm to, are you the one? Like we did we do something like intersections? Did we do something like even,
Yes.
let's say we are intersecting A with the, let's say, empty set? Did we do something like this?
Yes.
Okay, what is the answer there?
I don't think we did this.
Bayande. All right, so okay. We then let me just go through set laws. Then um, okay, I didn't do laws.
Which ones?
Set laws such as maybe
The ones for
let's say I'm saying A intersection A complement. I didn't do things like this.
let me check in my book.
So you don't study.
No, it's confusing.
What is confusing?
The terms.
There are no terms like me. I was
I
just
just I just I just I just remember we did we like a set of numbers, those like irrational numbers, complex those.
all right,
Then we went through that exercise, that one.
all right, all right. Okay. So nevertheless, now we'll be doing like we'll be proving sets. Is that okay?
Yes.
Okay. So let me just go through with you like some symbols used so that whenever you see that you don't get confused. So if someone is to tell you to say if you see something like A complement there, this is same as A. Is that okay?
Yes.
Yes. And again, if someone is to say like sometimes this complement can be represented by like this sometimes on these sets. Is that okay?
Yes.
Sure. So you should actually understand those. So if I'm to tell you to say what is A intersection, let's say empty set. So you know this is an empty set, right? It's a situation whereby we have, let's say, a box like that, which is the universal set. Then there's a set A there inside. Okay. So this set A, then what do we do then? We are intersecting with the empty. There is no, suppose there is just a set, like let's say there's a set, this A has 2 and 3. Then there's also an empty set of which doesn't have anything there. Okay. So now suppose we are intersecting A and an empty set. Do they meet at any point? Like, do they have any common thing?
No.
So this, wherever you intersect any set with an empty set, you should always get an empty set. Is that okay?
Yes.
Sure, which is an empty set like that.
That's always the answer.
Yes, whenever you are intersecting a set
It's
with,
always like that.
yes, please, like you represent this. Okay?
Oh,
Sure. So,
yes.
yes. So, and I have taught you to say wherever you see complement, like multiplying two complements there, they are giving, it's more like they are cancelling, you get the same A. Is that okay?
Yes.
Sure. So you find that we'll be now proving these sets, we'll be proving them. Okay. So they are what we call De Morgan's law in this
Yes.
set. They are what we call De Morgan's law. So these are just laws that actually some set obey. So and I will explain De Morgan's law. It's about when I have, let's say, a complement like that, let's say A intersection B, then there's a complement like that. Have you seen?
Yes.
Yes, this means that, I mean, like there's a complement on top there. Have you seen the complement?
Yes.
So this means that whenever you are, it's more like you are distributing this complement inside there. So this complement will multiply there A, that will be A complement. then the moment a complement crosses the intersection or the union, these things they change. If it was the union, it will come to intersection. If it was the intersection, it will come to union. So here we are crossing the complement as we are multiplying, which will give us union. Then the complement will also come on B there, and it will be B complement. Is that okay?
Yes.
Sure. Whenever a complement now like distributed is distributed inside, it will always cancel the, I mean it will always change the intersection or the union. That's the knowledge I want you to get here before we go into details.
Okay.
Gotten?
Yes.
All right. Okay, so one thing that we need to understand is that we'll be proving now these sets. So if I tell you to say A union A, what will be this?
A union A.
Yes, what will be the answer?
Mm,
Okay, so let me go through. Like whenever you remember under sets, we it's more like, let's say A has element 2, 4, 6, okay? And again we're adding because union is more like addition. That's what we looked at, right? Is that okay?
yes.
So if we are adding again,
Yes.
it will be like a 2, 4, 6 again, of which we report only one thing. So A union A, it will still give you A because you get what is in A. This is still the same set. Is that okay?
Yes.
So this is what I want you to understand. So let me call this as number 1. All right. So then number 2. Whenever we have, let's say we have A intersection A, are you able to see?
A intersection A.
Yes, like which one is good? Like the yellow,
Mm.
the yellow color or white? Which one like is visible there? Much visible.
Both are okay.
All right. So whenever you have A intersection A, it's more like we are going to intersect A to intersect where there is A only. Like this is one set, so you find that they fall under the same region. So you report A. Is that okay? It's more like we have A there as a set. Then again, we intersect A with the same A. We'll still meet in this A. Is that okay? You have seen?
Yes.
Yes. So this is why we give A like
Yes.
that. Okay. Alright. So that is the second one. So, again, if you are given something like A intersection A complement there. Okay. So, what will be this? I think I've been preaching this. What will be the answer there? I think I mentioned this.
Will it be A union A?
You know what, Kai? The thing is, let's visualize it. When we have something like a set A there, okay? We have a set A, then we are intersecting with A complement. You know A complement is this region, right? Outside A. So, do they intersect? The region which is outside and the region which is inside, do they intersect with A?
No.
So this is where this is the one like I gave you to say A intersection. Let's say empty set like that. Is that okay? Because there was nothing in
Yes.
this complement. In this outside A there is nothing. So this will give us empty set. Or you can use these brackets like to mean that empty. Is that okay?
Yes.
So coming now to something. Okay. So where you're not clear, please ask me, because these ones, whenever we start proving, then you need this knowledge. Is that okay?
Yes.
Okay. So what if I give you something like I give you a set to say A union empty set, like that. So I can use these empty brackets, or I can use the symbol Q, but I prefer using empty brackets. So what will be the answer there if you are to connect it? What do you think is the answer? Like A uniting with the A uniting it with empty set. What do you think would be the answer?
Will it remain the same like A since
Yes, good girl. So you know what, under sets, like you can't report, like you only report what is there. You know, it's more like you have 2 plus 0. What would be the answer?
2?
Yes. So good. So that's how we report sets, like that. Okay.
Yes.
So that is it. So that will give us A. It's more like you are adding. You know, union is more like adding. Okay.
Yes.
All right. So let's talk about now. Suppose you are given. Suppose you are given now. I think this I've repeated. Let me do it. A intersection empty set. What will be the answer now?
It will be like just the brackets, like nothing.
Okay, empty. So that's empty.
Empty set. Yes,
Mm.
empty set.
Okay, so like it's more like like you want to intersect something with nothing. What would be the answer? It would be still nothing, because they want to intersect at it. They don't have something in common. You get the point?
Yes.
Yes. So those are the things to consider. Please don't forget this. This knowledge is very important wherever you go. So here we report empty, like that. Okay.
Yes.
Okay. Okay. So now these, I want, it's not necessary for me to mention their names, but just to know how they work. I would have told you that this is the what, this is independence what, but some of them, they're just common wherever you be. Like I'll talk about what we call associative law. Don't even like waste, I mean, don't even, I just want you to master in a way that you won't forget, because if I introduce the name like this is the associative independence, that won't be necessary for you, but I want you to understand the way they can be behaving. Suppose you are given A union B union C. You know what? This is what you call, I want to create something like called associative law. So what I do, I will associate these brackets. So if I have A union B, I associate brackets like that. I will still have the same A union B, then union C. Then I will associate the brackets. I'll bring them here instead. Have you seen the way I've changed the brackets?
Yes.
So this means that, you know, we have been talking about union to say it's an addition. Suppose A is 2, then B is 3, then C is 4. You have seen? Then again here
Yes.
we have A, we said is 2, B is 3, then C is 4. You see? So and union is more like addition. You have seen?
Yes.
So all these brackets, they're just there to tell you that you first prioritize what is in the brackets when working out. Is that okay? Or even when you are solving those questions I gave you, I guess you prioritize first the brackets before coming to what is outside. Is that okay?
Yes.
So all these, they'll add up to 7. Is it 9? Yeah, 9. They'll add up to 9, right?
Yes.
So that's what actually associative law gives. because addition is the same and multiplication is the same. Suppose again I give you something like in terms of intersection A intersection B, okay, intersection C is equal to A intersection B. This is what we call associative. This one is mostly talked like in most of courses, like is talked about, okay? I just want to show you that, remember, we take this intersection as multiplication if we were to take in terms of that arithmetic, okay? So if I'm to associate these brackets also there,
So
I also associate.
they are like the sign changes to union.
I'm very sorry, this one is still the same. I just we associate the brackets, like I said. They should be uniform like that.
Yes.
Good girl. So that's how now it's still the same. Like, remember, even if we regard this one, we take this one as times, right? Suppose this is 3 times, then C later will come after working out these two. You have seen?
Yes.
You work out what is in the bracket, that will give you 6. Then 6 times what was outside, now 4, which will give you 24, right?
Yes.
Still the same if we were to say this is 2 times, this is 3 times 4. So that will give us 12. So 12 times 2.
24.
You see? So these, like, if you see brackets there, you prioritize brackets, you go work out where there are brackets like that. That's the meaning. Is that okay?
Yes.
Alright. You are tired?
No.
I can hear you yawning, like. Okay. So let's talk about now different sets. Suppose now we have, let me call this as okay, suppose you have different sets now. You have, let's say, A union B. What do you report there? How do you report such thing?
A union B. Don't you
Okay. Are there ways where you can simplify this? Like, are there ways of rewriting this? Okay, so there is no way of rewriting this. Like, you can own it again in reverse. This is same as A. I mean, let me start with B union A, which is still the same. Remember, union is about adding. So say B union A is still the same, right?
Yes.
Again, let me write the other part. If I have A intersection B, this can also be written as B intersection A. Is that okay?
Yes.
And remember, it's more like A. You know, this is like, let's take them like as numbers. If A was 2, then B was 3. This will give us 5 if you are to add, because union gives that addition vibe. But again, if we do on the other side here, we still get the same. We have seen the concept, right? Take them as if they are numbers, then you'll be able to see that they give really the same thing. Like, these things, they are more like addition and subtract, multiplication. You get these the boundaries, which is the intersection and the union, you know.
Yes.
Okay, so let me now go through with what we call distributive rule. Okay, Amanaka. So what we are going to do is, there is what we call distributive rule. So when you have A intersection like that, I mean, let me start with intersection, yeah? Then open bracket like that. Let's say B union C. Okay, so here this will be equal to, it's more like you are multiplying this A times that B, and that intersection will be your boundary. So we'll have A, okay, intersection B. Have you seen they have distributed? So you always group set like
Yes.
that. You group set like that. Then now there's this union which is there. So I'll put it as now our boundary like that between two combined set. Then times again the same A will multiply inside there with C, and that will give us A intersection C. Have you seen they have distributed?
Yes.
So it's more like let me just lab here. It's more like, again, I can tell you to simplify that what I've just expanded. You say what is common is A intersection. Well, A intersection to that will be B union. Again, there A intersection to that will give you C. You have seen? You go back to this one. Yeah. So what I'm trying to say is, if you are to simplify, you say what is common is A intersection. Okay, A intersection there, that will give us, are you able to see? That will give us B, then
Yes.
there's union, then we get C there. Okay, so those are the things, like we'll come back to that. So it's more like we are distributing, that's why it's called distributive property. Okay,
Yes.
sure. Okay, all right. So now the other rule, I mean the other set that we can talk of is, let me talk again the same distributive in the opposite way. Like if we have A union, still the same, then here they will be, they will just change in terms of these signs. Then there will have an intersection there, then you distribute again. This is what we call distributive property. So what are you going to have if you are to distribute like that, like imitate from what is happening above?
A
Yes.
A intersection B,
Mm-hmm.
like to close the brackets.
Yes, and you know what I've made? I was supposed to change there. Yes, but very good there. I want to see what you tell me.
Intersection.
Now, for, I'm sorry, here I was supposed to write union, so that, wait, here I was supposed to write union because this is, it's more like I'm repeating the same thing. But here I was supposed to write union. Is that okay?
Oh yes.
Yes, so that we actually differentiate them like that. So let me reverse it.
Oh,
Okay.
so it's going to be A
Yeah, let me just make it A union. A union, then B intersection C, like that. Is that okay?
yes.
Okay, let's go here. What will be that?
A union B
A union B, yes.
intersection A union C.
Intersection A union.
Union C.
Good.
C.
Good. So you find that what was there, it will be the boundary of the two. You have seen, it's more like this is another set, this is another set we need to combine with A. Okay,
Yes.
Okay, so these properties now, they are what we call set properties. All right, is there any question?
No.
All right, let's go to now proving sets, and you call it a day. Okay, so now I want to prove sets. All right, so so one thing that we need to understand is there's what we call De Morgan's law. Okay,
Yes.
so De Morgan's law, they are of two. Okay, so De Morgan's law, they are of two type. So suppose,
You've written something.
yes, I've written something in yellow.
The work that you, it's still there, like the work that you have. I
Okay,
don't know if it's a network.
I think it's my network. Let me wait for it. Are you able to see? What are you able
No,
to?
it's still there.
Okay.
The work that I'm doing, the
Okay. Just a moment. See something now.
no,
You can't see?
no.
Okay, just a moment. Are you able to see? What's there, by the way?